to the anus. So when you are saying that your sympathetic nervous system inhibits motility, in other words, it is working against the effect of peristalsis, because we do not want any digestion to be going on in the times of emergency. We want our energy to be channeled to the organs to release ATP that we need to do work in response of the harmful situation that you would have been faced with. And then we move on to the parasympathetic system, and there's actually sort of an to call it a mnemonic that helps you to remember the activities that are coordinated by your parasympathetic system. You can call it SS load or SS LAD, and your first S denotes sexual activity. Your second S speaks of salivation, and your L speaks of lacrimation. And whenever you hear of the lacrimation, it means tears. Remember the lacrimal gland and the lacrimal bone. And then we move on to U speaks of urination, and then D speaks of digestion, and the other D speaks of your defecation. You remember we said that this part, your the U and D is innervated by the sacral, by the nerves that are found on the sacral, that is specifically S2 to S4, and this has got to do, we have highlighted that it has got to do with the control of your blood and also release of your defecation. So this has got to do with the which has got to do with your dissenting colon, rectum, in order to release the feces that it holds. So that's about it as far as the peripheral nervous system is concerned. But maybe before we put a lid on that, we'd love to see how your parasympathetic system and your nervous system works in terms of digestion. So you realize that, and maybe trying to tie this to like what this works outside of the enteric system. We have seen that it works outside the role of your central nervous system, but now we're looking at digestive system as far as the with the involvement of your central nervous system. So you realize that initially digestion kickstarts as a result of the detection of smell or taste, and now what we need to understand is which particular nerve is responsible for the innervation of that of the sense of smell and taste. You realize that we were speaking to the glossopharyngeal nerves is the one that innervates that. And once that happens, not only about smell, taste, that is we're talking of movement, swallowing, in terms of the swallowing. And now what we want, it also has got to do with motility, that is peristalsis, the movement of your food item, down your GIT tract. I'm trying to see that I won't leave anything that has to be taken into consideration. So you know that the sense of smell is actually transduced by your parasympathetic nervous system, and already mentioned that. Let me see if there's anything that I have left out. And then your parasympathetic, actually, which is involved in digestion, and mainly it is via the cranial nerve called the vagus nerves. And we have already alluded to what the vagus nerve does as far as the parasympathetic system is concerned, but maybe you may want to put that into consideration. We are talking of control of your digestive centers, such as your stomach, yeah, because it's digestion in those organs. Does it control it controls the stomach, it also controls your kidneys, it also controls the spleen, and quite a number of accessory organs that deal with the digestion. And the other thing that your parasympathetic does is the stimulation of acid production in your stomach, and that is your vagus nerve that controls that. And the other digestive accessory organ that I had forgotten is the pancreas. And so this is the vagus efferent nerve that does with the innervation of all those centers as far as regulation of the GIT is concerned. Let me see from my notes if there is anything that is or that is left out. We have alluded to the fact that with the release of your what do you call it? The release of with the release of the neurotransmitter that you call adrenaline, which is also known as epinephrine, it results in the constriction of blood vessels. And why is that important as far as the GIT is concerned? It is important because it results in less perfusion of blood to the intestines. Because we don't want digestion to take place, so less perfusion of blood to the intestines, and it's channeled to the other organs in response to the fear and flight situation that we are faced with. And that's about it as for. And how does this enteric system controls regulate the autonomic nervous system outside of the central nervous system? Of course, it's supposed to, it works with mechanoreceptors, it works with chemoreceptors, it also works with osmoreceptors that sense. Mechanoreceptors respond in the presence of food. Chemoreceptors is a response to dictates. These are receptors that detect changes in the chemical composition of your GIT in response to the secretion of gastric juices that aid in your digestion, and that can intrinsically control your autonomic nervous system outside the aid of your central nervous system, that is your brain and your spinal cord. That is how it works. So I believe that now we have managed to appreciate how our peripheral nervous system works in depthly, and the kind of activities that it coordinates, and the relationship that exists between our peripheral nervous system and the nervous system, and our peripheral nervous system and the central nervous system. We have said that the central nervous system is actually the control center, with our peripheral system acting as the front line. So that's about it as far as our peripheral nervous system is concerned. We'll meet again as we look into the central nervous system, that is, as we cover the spinal cord and the brain in detail. Good night.